Okay, hello everyone. Nice to see you all. And this class, we're going to continue with the computational methods engineering, and we're going to talk about some important functions in terms of the structuring of our coding. So these will include logical functions, selection structures, and repetitions. So let's first do a quick recap of our last class. Last class, we talked about MATLAB built-in functions, right? We said that MATLAB actually has a whole library, right? Many functions that are built in to help us with our analysis. And also it depends on what type of toolbox that you install onto your MATLAB, right? So we said that we could use the help feature to get an understanding of what MATLAB each of the functions does. And then we talked about some basic mathematical function, like the logarithmic functions, trigonometric functions, and yeah, rounding functions, floor, ceiling, right? Fixed, discrete mathematics function, right? There is an array of them. For example, if you want to do the factorial, right? So these are in the discrete mathematics functions, trigonometric functions that are dealing with the angles calculation, data analysis. So we said that there is sum, there's average or mean, right? And then there is the, for example, sorting the data by rows. So especially we give a few examples of the data analysis that basically deal with the actual weather data, right? So under those situations, we also need to pay attention that in the table, there could be scenario where the cell value is not a number. So if it is not a number, then when we use these functions, we have to give the option of omit not a number, right? So we just type in omit NaN. Random numbers, we use the random number to simulate some noise onto a song, right? And then eventually the complex numbers. Okay, so that's it for the MATLAB built-in functions. I would say try to use these built-in functions for your day-to-day homeworks, right? Or try to use MATLAB for your day-to-day homeworks. So these will really help you build up a library of knowledge, right? In the future, you can easily get back to these functions and get to learn what was done. It's far better than the paper and pencils. Okay, so this class we're going to talk about the programming structures. So I would have to say that so far we have only been using the structure of the sequence when we create our own programs. So for example, when we're trying to create a table of converting from foot to basically meters, right? I remember it's mile per hour to meter per second, right? So then basically you will first generate an array and then convert the array with the appropriate factors and eventually print out the arrays or the table, right? So everything is based on sequence. But what if there is selection? For example, if under certain condition you convert meter second to meter per second to mile per hour, but under some other situation, you convert mile per hour to meter per second, right? So you could see that basically that this conversion is needed when you're moving, let's say, from the countries that uses imperial units to countries that do not use imperial units, right? You need this conversion. It's almost like translating different languages. So there is a split, right? The selection of the structure. There could also be the repetition structure. For example, if you want to test, let's say want to conduct certain calculation until after a number of trials, right? A number of iterations, for example. Let's say if we want the system to do 100 iterations, you don't want to create 100 sequences to do that calculation. You want to create loops, right? To each iteration, it just repeats or takes whatever value it gets from the previous iteration and keeps doing all of these calculations, go to next iteration, so on and so forth. So this class, we're going to show basically how to create these special structures, right? And also, basically, we'll also tell how do we create them. And before that, we need to first know the logical functions and also the, let's say, the logical operators, right? Or the relational operators. Okay, so basically we can use those logical values or relational operators to decide whether we want to select certain branch, select certain sequence, or we want to continue with the iteration. Okay, so the first one is the relational operators. The relational operators perform the element by element comparison between two arrays. They return a logical array of the same size with elements set to logical 1, which is true where the relation is true, and the element set to 0 where it's not. So as a simple example, for example, if we want to see the use the relational operators, right, to see whether it's true or not, we know that 2 is larger than 1. If you type in 2 is larger than 1, it will return you a value of logical 1, which means it's true, right? And if you do 2 is smaller than 1, then you're going to get 0 because that's not true, that's false. And we can also try 2 equal 1. So this is not going to work because equal, the equal sign, basically it's assign values. There's no way that we can assign the value of 1 to 2 here. That's why you have this error here. But indeed, there is a function of telling whether the two values are the same. So for example, you can define A being 2, A being 1, and then B being 3 minus 2. Okay, so you want to know if A and B are equal. So what do we do? You can do A equals 2 equal signs B. Okay, 2 equal signs means whether A and B are equal. You can see that A and B are equal, so that's why you get the answer of 1. You can also try, for example, B set it to be 2, right? And then try again, you'll get 0. Okay, so you can use these relational operators to get true or false. And then based on the result of true or false, you can go on to select different branches, or you can go on use these true or false function to design your repetition or loops. For example, if you want to run the loop for 50 times, then you can just give it criteria of whether the loop number or the iteration number is larger than 50, right? If it's smaller than 50, you keep running it. If you're larger than 50, it exits from the loop. Okay, so as I said, there are multiple relational operators, like the first three, we already talked about it. There's also the not function, right? So if you do, let's say say x equals 2 larger than, okay, so you can see that x is a logical value, has 1. And then if you do the tilde of x, you'll get 0, right? That's not 1. Basically, it's 0. This is true or false, right? Not true means false. You can also add the equal sign here, right? It's not only greater or smaller. It could be greater or equals, less than or equal, or not equal to, right? So not equal to is just a tilde with the equal sign. Okay. So for example, the logical data type, I mean, basically the X is what we call the logical data type, right? So this is another MATLAB data type. It's either equal to 1, which is true, or equal to 0, which is false, right? So we tested 2 or 1, but basically here's 4 smaller than 5, that's 1. 4 smaller equal than 5, 1. 4 bigger than 5, 0. Bigger or equal, 0. Not equal to 5, which is 1. Okay, so the relational operators and round-off errors in numerical computations is something that we need to memorize, because we need to know, because we said that basically these computational tools like Excel or MATLAB, they use Taylor series expansion to approximate values. We know that, for example, pi, which is an irrational number, right? It has endless number, and the numbers in the different digits, they do not repeat each other, right? So that's why there's always a truncation error. So for example, we know that the sign value of pi in actual situation should be 0, right? But if you type in MATLAB, you can see that what you get is a very, very small value, which is not 0. So under this situation, if you want to test whether sine pi is equal to 0, it will say not, right? Because these two numbers are different. So this is related to the truncation error or the round-off error of the MATLAB programming. So under that situation, the best way is actually to do a rounding or set up certain criteria. So if, let's say, sine value is smaller than 10 to the fifth or 10 to the 10th, then set the sine value to be 0. Okay, so in that situation, you have to manually set the value so that you can use certain of types of these relational operators. Okay, so this is further explanation, right? This is truncation error. And then there's also logical operators. Okay, logical operators basically can operate these logical data types, right? So we said that these true or false, right? So you can operate them as well. So for example, there could be that you want to test two relations. Okay, so one relation is 2 greater than 1, right? The other relation is 4 greater than 3. Okay, so you could further test, right? So you can test whether both of these are true, right? Or one of these are true. You can basically do the AND, logical or logical not, right? Sort of showed the not earlier. Logical AND, to do that, you would just do X and Y. You'll see that it's 1, right? Or X or Y. You see that it's still 1, right? So basically, um, or means if any of these is 1, then you get the result of 1. But for AND, if any of these are 0, right? Any of these is 0, then you'll get a result of 0. So we can try, let's say, now let's set X equals 2 smaller than 1 or 22 smaller than 1. So now if you test X and Y, you're going to get 0, and X or Y, you're going to get 1. So this is logical and logical or. So again, this could be helpful when we set up conditions for building up these selection or repetition, because a lot of times when we decide which branch to go for our selection type of structure, it may be contingent upon different conditions or a set of conditions, right? We have to select certain branch when all the conditions are satisfied, right? We have to select the condition where the other condition, if none of these are satisfied, right? So a lot of times it's not only one condition, right? Because of that, we have to use these logical operators, right? Remember, one's logical data type, right? Or the relational operations, right? And then the logical operators. So we sort of tested this already, right? If you have A being true, so you can test, for example, you can type in A true, right? So that's logical type. So basically the true here is a recognized string in MATLAB that will give it a logical value of 1, right? You can type in B equal false, right? And then you can do A and B. And I think we can also do this, right? So if you just give the a value of 1 and then try A and B, right? It will actually convert A into a logical data type. Although in the beginning, A is basically a value or number, right? A scalar. But then actually, if you do this logical operation, it's going to convert the A into a logical data type, and then you're going to get logical data type. We can also try, let's say, setting B to be a scalar and then do A and B, right? A and B is still recognized as a logical data type. So basically, no matter what these values are, right? So it's going to recognize, let's say, if you set B to be 0, and then A and B, you're going to get 0. Okay, so so basically, it means that these inputs can be numerical, and then you can conduct these AND or operations. Okay. And one thing we need to pay attention to is when you do the relational operations, it's not only being applied onto single elements. Basically, when you conduct these comparison, it's being conducted element by element within an array, right? So this is an example. So when you have x equals 1, 2, 3, 4, 5, and then y equals, let's say -2, 0, 2, 4, 6. And then when you do x, let's say x bigger than y, so you're going to get 1, 1, 1, 0, 0. Basically, you're going to get an array that contains these different data types. Okay. So it's not only by one element. So this is something we need to pay attention. Basically, again, if we go back to the structure here, so remember what we're comparing about, right? It's not only when you're having an array of numbers, array of values, basically it's comparing one by one. And if you want to use certain branch here, let's say if all of these are true, then basically when uh, it will only go to the branch when all of these values are one. So we're going to talk about this later on when we discuss these selection structures. Okay. So then similar to the hierarchy of calculation, there's also hierarchy of operation. So you can see that basically you could have x equals 2 larger than 1, right? So then if you write this code out, what does it mean? So is it going to conduct 2 larger than 1 first, or is it going to conduct x equals 2 first, right? So this will basically be determined by the hierarchy of operations. So basically, the order of operation is first arithmetic, second relational operators, right? So basically, you would do the calculation first and then conduct the relational operation. And all of the not operators and all and operators evaluated from left to right, and eventually all operators evaluated from left to right. Okay, so it may be quite confusing. So basically, you can see that the relational operators, which is comparison, comes first, right? And then the not operators, and then the and operators, and then the or operators. So if you think that this is basically, I can quickly write something out. So 4 larger than 3, or 2 larger than 3. Okay, so what this means, or let's do 2 plus 2 larger than 3. So what this means is that inside this hierarchy, or due to this hierarchy of operations, inside this equation is going to conduct the arithmetic calculation first. We're going to get 4 larger than 3 first, right? 2 larger than 3 first. You are going to get 1, right, which is true, and then false. And then after that, we don't have any and here, and then it's going to be the or, which is 1. So you're going to get x equals 1. Okay, so sometimes it may be difficult to memorize all of these sequences. So that's why, just to be sure, you can actually do this. So never hesitate to add different brackets, right? Add parentheses um, to your code so that it's clear, right? So you can see that this parenthesis correspond to here, right? This is the whole thing. And then here you have this parenthesis getting the 4 first, right? Addition first, and then compare against 3, and 2 compare against 3. So you're going to get the same results. Okay, so this can, adding the brackets can really help explain your code. Okay, so the logical functions, basically there are functions to conduct these logical analysis. So for example, the most widely used function is the find function. Find function is going to find within your array whether there are elements that satisfy certain standards. Okay, so one example is this. So we can write the V out. Okay, so this is our V, which is basically a matrix that contain 2 rows, 6 columns, right? Some numbers over here. So it may be there may be a scenario that you want to see whether there is an element that contain exactly certain number. So for example, you can do V equals 4, okay? So is it equal? Or this double equal sign is called is equal, right? Let's see, equal to. Basically, double equal sign is equal to. So it's what it's going to do is it's going to find, it's going to look for the element that is equal to 4. Okay, so then you can use the function find v equals 4. Okay, so if you directly type in find v equals 4, you're going to get an answer of 11. So it actually gives you the index of the element that has a value of 11, has a value of 4. So you may wonder why, well, why do you get 11? How is it, I mean, this is 2 rows, 6 columns. How is index 11 being 4? Right? So remember earlier when we talked about the indexing of the matrix. So in terms of the matrix, the way you count the element is column by column, right? You get element 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? This is element 11. Or you could also do what it's showing in here. You can name the row and column of the uh, element, right? Find the value that has row, column, that find the element that has a value of 4. Okay, so it's going to tell you that row 1, column 6 is 4. And you could also try this. So let's just quickly test this one. V equals 4. And actually, when you um, do this comparison, it's actually going to give you a logical data array, right? So it has the same dimension compared to your original matrix. It has 2 rows, 6 columns. And then it's going to leave a element of 1, which is true, corresponding to the element that has the value of 4. Okay, so basically it's a comparison of each element, right? So the find function will give you or return you the index of the value that equals 4. Okay. So this is the logical function, especially the find function. And actually, I was have to say that the find function can be quite helpful when you're dealing with data sets that are trying to look for certain type of data, right? So you can see that this is a data that we tested, right? So now let's say that we have quite a lot of data, right? A little bit more. We have one more row. So this is the one more row that I added. So let's just type this in. So this is our new data. So now you can see that we basically have 3 rows, 6 columns. And let's assume that this is, let's say 3 sensors, right? Sensor 1, 2, and 3, and then they're reporting, let's say PM 2.5 concentration. And we know that the sensors, sometimes they're not reliable, right? They can give you extremely high and not realistic values. And we want to set these values to be not a number because it has to be some electrical malfunction that give you these exceptionally high values. Sort of like flagging the data based on some general understanding of the data. Okay. So then our goal is basically to find the data that has value above 100 and replace the data points by not a number, right? Basically telling the sensor that this is not true. Okay, so then how do we do that? So basically earlier we said that we could use a find function to locate the index of the value that satisfy certain standards, right? So we can just define a parameter called index, find v larger than 100. Okay, so it's going to give you the index of 14, right? Quite obviously, it's the element here. So we can count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? So then what we can do is we can just replace the element 14 within this V here by not a number. Okay, so you can see that now the element here is replaced. Okay, so this is basically an easy way for us to process the data or sort of flag the data or remove the data. So basically in the future, if you are averaging the data set, right, trying to get the mean value of certain sensor, then the data is flagged out or is removed. So then you can get more realistic readings from the sensor. Otherwise, if you average everything, you're going to get exceptionally high values. Okay, so you can use the find function. And also, if you recall earlier, we said that we could just directly do the comparison, right? So Now it's already been changed. So let's define it again. Okay, so this is our data set. And then we can directly compare the V against 100. So actually you can see that the uh, it's giving you the index or the location of the value that's bigger than 100. So now another way to replace the data is to just place this entire matrix into the V to be not a number. Okay, because here, since you're getting all of these elements out, right? All of these data type out, and you can directly put the data into this matrix, and then you're going to only get this value here, and you set it to be not a number. Okay, so this is another way in which can sort of reduce the coding effort, right? So you don't need to type in the find anymore. You can directly find out what elements have values larger than 100 and replace that directly using the index, right? Placing the index over in this matrix and set it to be not a number. Okay, so this is, I would say, at least in my day-to-day work, I use this function quite a lot to process my data set, right? So it can help you screen out certain data that does not satisfy your standard. Of course, you have to be cautious about not altering the data. So here, what we're showing is that you can see the data like 800 something is definitely an outlier, right, compared to the rest of the data. But you have to justify the removal of the data for sure. Okay, so apart from the find function, there are other types of logical functions. For example, you can tell whether the input is a character, whether the input is an infinity, whether the input is not a number, whether the input is numeric, whether the input is empty. Okay, so we've talked about the not a number. So you can actually try, let's say, define A being not a number, and then you can try if A, oh no, is and then in A, right? You can say that you can see that it's actually one. So it's asking is A not a number, and it's giving you one. And you can also test is infinity A, and you can see it's zero. Okay. So again, we can use these logical functions or the result from the logical functions to decide which branch or which sequence we're going to choose from the selection type of structure. Okay, so this is a quick example problem that basically show us how we can use the find function and then how we can use that for data analysis. So let's quickly read through this problem. So the amount of the sea ice surrounding the Antarctic continent varies dramatically during the year and from year to year, right? This is the figure. So basically this is the summer, right? September time is sort of the summertime in the Southern Hemisphere. February is the, oh no, September is the winter time and February is the summertime for the Southern Hemisphere. So that's why you can see more ice during the summertime in Southern Hemisphere, less ice during the, oh, did I say it wrong? So more ice during the winter time of the Southern Hemisphere and less ice during the summertime of the Southern Hemisphere. So it says that the following data, which I already converted into this Excel spreadsheet, were obtained from NOAA, the National Center for Environmental Information website, and represent the extent of sea ice during September when maximum yearly occurs and February when minimum yearly occurs. So it wants us to plot the September values and February values versus the year and add a line representing the average ice extent for 1979 to 2010 and of 3.04 million square kilometers for February and 18.79 million square kilometers for September. So basically, February you have much smaller ice, right? And September you have much more ice. So, and then the B and C are about using find commands, right? To find commands to determine which years exceeded the average September values and which years were lower than the average values for February. So sort of see the maximum or minimum by which year, or find the anomaly from the ice coverage. So first, let's create a function, right? So we can do just name this file or the M file, right? We don't have to use the function. So we can do example 6.9 problem, and then I save it. Problem 6. Okay. So as I mentioned, this is the Excel spreadsheet. So let's quickly open this up, and then we need to import the data. So this is the data set we want to import. And if you can see, it's from 1979 to 2016, right? So this is the data set, and this is empty. So we can replace that by not a number, and then we can export it as numerical matrix. And let me see. So we shouldn't select the text. So let's only select the number. Okay. Numerical matrix and import. Okay. So now you see that there is a new data set, right? Or new matrix. And then if you double click, this is basically the CI's data, right? So the variable name is CI610 1979 to 2016. So you have the year, you have the CIs for February and no, CIs for September and CIs for February. So let's quickly save this data file into a .mat file. So problem 6_9.mat. So in this way, in the future, when we try to use the data, we can just load and then let's see, CI610. No, it's called problem. Okay. And then after you load the file, actually, you will directly have the variable name being the same as the CI610. So let's just copy this name here. Right, so we can name it, let's say data is equal to this one. So let's just rename the data set so that we don't um, we don't um, we don't have to, let's say, to type in this variable again and again. Okay, so this is data, and then we can quickly run this. So let's clear, and then run the function. So basically, this is the data, right? This is the data set we want. So now the first step is to plot the September values and February values versus year, right? So we want to do the plot. And if it's versus year, so then we know that it's going to be, we're going to show the X value first, right? So that's going to be the first column, right? Second column, first column, third column, right? We can also determine which color of the line we want. So for example, during the summertime, let's use R, and then during the winter time, let's use B. Okay, we can run this. So this is our figure, right? Of course, we can also adjust our x-axis, y-axis just to label them, right? So we can also set the limits, right? So we can set x_lim or y_lim to be 0 to 24, just to make it look a little bit nicer. And also we want to add legend. September, Feb. So we can even set it to be 25, so it shows all the y values here. Okay, and then X label, year, Y label, sea ice coverage. So you want to show the basically the unit for your for your plot as well. Let me see. Basically, they're going to carry the unit of million squares km squares. Okay, so now we run this again. And this is our figure, right? So you have the x-axis, the y-axis, and then further this plot, for this plot, it actually wants us to add two more lines, which is the line of 3.04 for which is the average of 1978 to 2010, right? So basically to show a line that's the average between 1979 to 2010, and then to basically mark up what are the years that has sea ice values that are above or below, right? And then use them as a reference. So to make these horizontal lines, of course, we cannot use the solid lines anymore, right? Maybe we can use the dashed lines. And also, we need to specify the starting point and the end point. So we said that to make more plots on the more line plots on the same plot is to use the hold on function. And also later on, we need to hold off, right? So then we can plot. So to make a horizontal line, we actually just need the starting year and the end year, right? We know that the starting year is 1979 and the end year is 2016, right? And then we can just, this is the X, right? The Y value will be 18.79. So these have the same Y value. Okay, so the same thing for the X. And then Y, 3.04. And okay, so this is the code. Let me just minimize the current directory a little bit. Okay, so basically now we have these two lines, but then at the same time, we want to give them the specific colors, right? Because we don't want to confuse all of our data with the same type of line. So we said that during the summertime, we could use the red color, but we can change the line style. Let's change it to be dashed lines. And then for the winter time, we can do the same and then change it to dashed lines. And then we can hold off. And further, in terms of the legend, we can do September average, right? And then February average to specify these two additional lines. So now if you run it, you can see that we have these two horizontal lines marking the average and then the actual sea ice coverage, right? So basically you can see that, I mean, starting from 1990, you see more fluctuations, right? Before that, it was a little bit more peaceful, and now you have more fluctuations. So then, in terms of this problem, I mean, this is how we deal with the part A, right? So in terms of this problem, it wants us to use the find function to determine which years exceeded the average September values for this period, right? So the way we can do that is just to find or try to find the index, right? Index summer or September of find. We need to find the data set of column of 2, right? Bigger than the average, which is 18.79. Similarly, we can find the index of February of column 3 smaller than 3.04, sort of trying to find the extreme conditions, right? And with these index, we can directly put the index into the first column, right? Because these will, let's see, if we run the function, right? So then it's actually going to give you the February index and September index, right? And then to find the years, actually, you just need to place these index or give these index to the first column, which are the years, and then it will return you the years directly. So data, and now you shouldn't be using the colon sign anymore because now you have the index and you can directly put it over here. Okay. Um, that, and then one. Okay. So now if you run it, so you can see that it's going to give you the years that exceeded the average, right? And the years lower than average. Years exceeded the average for the summertime and then lower than the average for the winter time. You can quickly check these also, right? So for example, 1980, right, is over the average. This is 2014, right, above the average. And then 2015 is actually right, 16. Yeah, 2015 is lower than average. 2016 is actually equal to the average, right? And then for the let me see, September shouldn't be called September, it should be called February, right? The years that are lower than the let's say the average will be shown here, right? 2016 is definitely lower. 2011 is also lower. Okay, so this is how we can use the find function and to basically generate some information, right? If you think about, let's say, conducting the same analysis in Excel, it's actually going to take a little bit longer time. And here we just directly import everything. And it's not only about time, but also give you a good sense of what data you're dealing with, right? So you can basically convert all of those functions in Excel into just typing in some code into the MATLAB. And of course, if you want to keep the code for a longer time and then self-educate yourself, right? Educate yourself on why you conducted certain analysis, you should definitely add comments. Right? So here, due to the time, I just skip the comments over here. So I would say this is a nice example of how we use the find, basically the logical function to process the data. Okay. So now since we know the logical data type and logical functions, we can start to talk about these different structures, the selection structure or the repetition structure. We'll start from the selection structure. So basically, if we want to use the selection structure, we need to first understand some tools that people use to create different structures. And these are called the flowcharts and the pseudocode. Okay, so I would say these are not required in terms of the coding, but when you're dealing with larger sets of coding, actually they will come in handy, right? They can explain what you're trying to do in terms of the coding. So basically for simple programs like the ones that we talked about earlier before in earlier classes, like creating the conversion table, we can just use the pseudocode. So what pseudocode means is just typing out all the steps in comments, right? So outline a set of statements describing the steps you will take and convert these steps into commands in MATLAB program, and then insert appropriate code into the file between the comment lines, right? So for example, a set of pseudocode, if you want to create a program that convert mile per hour into foot per second, right? The output should be a table complete with a title and column headings. And this is an outline of the steps that you might follow. So first define the vector of the mile per hour values, convert mile per hour to feet, combine these vectors into a matrix, create the table title and display the table, right? So you can just type in your M file these lines, right? Define the vector, convert everything, and then basically your steps into the comments. And then under the comments, each comment, you can type in your code. First, define the vector. You have the vector defined over here. Convert mile per hour into feet per second. You do the conversion. Foot per 1 mile is 5,280 foot, right? And then divide by 3,600, that's hour to second. And then combine these together, display a table title, and display the table. And this is how the pseudocode work, right? So for more sophisticated programs, actually, people will use the flowchart or a combination of flowchart and pseudocode. So basically, you want to explain why you created certain type of code or certain type of structure, right? So if you convert the pseudocode of the previous problem to a flowchart, right? So basically, you have different symbols to represent what type of procedure you're taking, right? For example, the oval indicates the beginning of the code. The let's say this shape here is used to indicate either the input or output, right? The diamond indicates the decision point, and then rectangles indicate the certain calculations or certain processing. Okay, so for example, if you're thinking about the table, right, creating the table for the mile per hour to feet per second conversion, you definitely have the start, which is oval shape, right? And then you have these different calculation steps being the rectangles. And then you have these parallelogram, right, um, to indicate whether input or output, right? So here is specifically is an output step that you convert or you basically display the title and display the table, and then the end. The end is also shown as the oval shape. Okay, so I would say these flowcharts are generally more widely used for a little bit more sophisticated um, programs, and especially when you are having the structures that involves the decision, right? So for example, the parallel, the selection, and the iteration, these will be a little bit helpful. Okay, so one example is the sin C function, right? The sin C function is here, right? It's being used in many engineering applications, and then this function has two widely accepted definitions, which is one having this term and the other having this term, right? So both of these functions have an indeterminate at x equals 0, okay? So when x equals 0, we can use the L'Hopital's theorem, right? So basically to take the derivatives, right? So sine x, if you take the derivative, that's basically cosine x, right? X take the derivative, that's 1. And when you plug in 0, then you get 1 over 1, which is 1, okay? So here, it wants us to create our own sine C function, right? Which takes this second form. But if you directly use, let's say, type in sine 0 divided by 0 in MATLAB, it's sine 0 over 0, it's going to give you not a number, right? So what that means is that when you create your own function, you sort of have to define, like, when it's very close to 0, if it's very close to 0, then you are going to set the function to be directly 1, okay? So if you want to convert this problem into a flow chart, this is what we have, right? It's a start, and then you find the index of the input. Let's say you're trying to input an array, right? So then you find the input or index of the input that has the element that are close to zero. If it's very close to zero, right? If it's within 0.0001 from zero, then you directly give the output to be one. And for the rest, you find the index of the input values or the elements are not zero, then, right, you will give the output of actual calculation, sine x over x. Okay, so based on this definition, right, we can just create our own function here, which is function output sine cx of x, right? So x can be an array. So I will sort of just skip the pseudocode over here, right? You can see that pseudocode is basically the comments that tells you what each step is doing. So first tells you, oh, this function does find the value of sine c, right? And using the definition of sine x over x. So since x is an array, so we have to first find out the index of this array that has elements that are too close to zero. So then x is smaller than absolute, or the absolute value, x smaller than 0.0001. You can even make it smaller, 0.0001, okay? And then we will directly give the output of set one index to be one. Okay, and then for the rest, 2 larger or equal to 0.001 will give the you will give the value of actually the actual calculation, which is sine of x and then dot divide x. Okay, so this is how we define the function. Actually, you can type in or add in this find over here. And actually, if you don't use the find, it's also going to be okay, right? As we showed earlier. Okay, so this is our function. So to type, make sure that all of these are correct. Okay, so now we can test it. Sine c of x, right? So we can do, let's say 0. We can test 0 first. 1.5, 10, right? Yeah, so we also need to set it over here. Set to, right, to specify. Basically, these are the elements that are not close to 0. Okay, then we try sine c again. So then it's going to give you the value that looks like this. And if you want to basically plot it out, right? So you can do plot x, let's say -1, let's do -10, and 0.001 to 10. And then we can do our own sine cx, same thing, right? So this is going to return you the shape of the function that we just created. Right, so this is our own function. So basically, what it does is that when the x value, the input value is close to 0, right, within 0.00001, it's going to manually set these data point to be 1, right? And since we set it to be very close, so you won't be able to even recognize because the step here is 0.001, right, which is much bigger compared to the step over here. So basically, the only element that satisfy or that is plotted over here is 0. It's set, the value is set to be 1. Okay, so this is the example over here about how to use the flow chart, right? So you can see that even for this program, it's still a sequence, right? It's still doing one sequence. It doesn't have the selection. So now in terms of selection, we can talk about the if, right? The if construct. So the if end construct, or which is a decision construct, is useful when the relational operations are used to decide whether or not to execute a sequence of commands. So you can use them for displaying messages. You can use them to prevent undesired operations. For example, you may wish to skip log of x command for x smaller than 0, especially if you want to get some meaningful results, right? Of course, it also mentioned that MATLAB deals with complex numbers, so you could put in a negative value, but in terms of engineering, it may not carry much of a meaning over there. Okay, so the basic if construct has the following form. So let's just create a new script, right? Let's just call it test. Okay, so if you want to use the if construct, you will actually always have to type in if and end, right? So if there needs to be certain criteria, certain comparison. For example, if you do if, say, x equals 2, right? Predefine an x value, right? If x bigger than 1, then it's going to execute all of the code or the commands you entered over here, right? So you can type in 1 plus 1, right? Or 2 plus 1, sort of different code here. So you can basically run this, right? You can see that it actually run these two codes. And then if you set it to be 3, right? If x greater than 3, which is 0, right? Or false, then it's not going to run all of these codes, right? So basically this will give you a sort of the selection, because it really depends on what you get over regarding the x, and the x can be a result of some complex calculations, right? So if this comparison is true, it move on to the action. If the comparison is false, the program skips and go to the end statement. Right. So, and also when you, as I mentioned earlier, the comparison, if that's an array, then all of the elements are compared, right? So as we compared earlier, when we compare X and Y, and then each of them have 5 elements. So if you want to compare arrays, then the if construct will require all the elements to be true, right? So it cannot be just one element, right? So for example, 2, 2, or 2, 3, right? So then if you define x being an array, and then if x bigger than 2, we know that it's going to be 0 and 1, right? If it's 0 and 1, it's not going to run this, right? But if it's greater than 1, then it is going to run the code inside the if and construct, right? So this is something that we need to know, because it basically is not running the comparison element by element. It's conducting comparison as an entire array, and all of these different elements have to satisfy this comparison. Okay, so similar over here. So if define an array and say that if G is smaller than 50, you want to print that G is less than 50, it's not going to run the code over here, right? Because you are going to have the value bigger than 50, and then they do not satisfy this condition, right? For example, 80 is larger than 50, so there's no way that you can run the command over here. So basically it skips to the end. And for the array, or for this if end construct, there's also a quite helpful condition, which is the else, right? So similar to how we speak, if something happens, then we have some decision, else we have some other decision, right? So let's say if x bigger than 1, you have 1 plus 1, right? If else, then you have 2 plus 1. So then if you have the value of 2, basically it will go here, right? You're going to output 2. right? If you give the x value of 0, then it will actually go to the else command, right? You'll get then 3 as an output, right? So here, this is another example. So for example, we can do x equals some input, right? What is the number, right? It's going to ask for a number to be input over here, right? So then we can have if x bigger than 0, then y equals log of x, right? Else you let the function to beep and then have print and also print a error message, error, right? So then you can run this. It's going to ask for a number. Right? You can put in 10. Well, since we hide this, we cannot hide it. If you put in 10, you have y equals this value, right? But if you run this test again, and then give it a value of 0, you're going to print the error message, right? And also beeped. Let's try again, right? So this is the if and else construct. So in addition to if and else, there's also else if, because you could basically have quite many different options, right? It's not only one or two, it can be one, two, three, four, five. So there's also else if clauses, right? So what you do is basically you type in else if over here, and then, for example, if x is larger than 0, right? Else if x is larger than -2, right? Because if x is larger than 0, these are basically the positive values, right? Else if it's between -2 and -2 and 0, right? You can type in some f, let's say print f, x is between -2 and 0. Right, you can do another else if x bigger than -4, and then 4 and -2. Yeah, so basically it will help you determine, go to different branches, right? Go to different selections, and then basically give the output accordingly, right? So we can try. Right? So we can try this test again and then type in -3, right? So we know that if it's -3, definitely it's not going to go here. Else if x bigger than -2, which is not the case. Else if x bigger than -4, it satisfies this else if. So it will output x is between -2 and -4. Right? So this is if, else, and else if. But one thing we need to pay attention is that the else if is always above else. Okay, else is sort of the concluding condition that if anything else is not satisfying the condition, right? Everything else is not satisfying the condition, and else, that's the final selection that we will go to. Okay, so this is basically one example for assigning grades, right? So if the if family statement is used most effectively when input is a scalar, right? So just a single number. So create a function to determine the test grade based on the score, and assuming that single input is provided to the function, the grade should be based on the following criteria. So basically, this is giving you the if-else structure, right? So if x is bigger than 90, right, or bigger than 90, then you output A. Bigger than 80, right, its output is B, right? So also note that here we actually didn't constrain x to be smaller than 90 and bigger at the same time bigger than 80. It's mainly because if it's really larger than 90, it's already exiting through the loop here. It's acting through this structure, right? So for example, else if we didn't further specify x to be smaller than 0, because we know that if the x is bigger than 0, it's already using this clause and jump to the end, right? It's already using this command and jump to the end. So basically, we can use this set of code. Let me just copy everything and put it over here. So we can do grade. What is a grade? Okay, so we can type in, let's say 100. It's A, right? What is a grade? 75, right? It's a C. So basically, it's using the if and else if conditions to go through the different selections, right? So if you show that in the flow chart, you have the start and then the decision point. If it's true, right, you go through this output, right? The result is A, right? Go to the next decision point, right? If it's true, X bigger than 80, right? Go to B. If it's true for X bigger than 70, go to C, D, and then else, the result is D, okay? So this is the if and else construct or the structure. So we could also use the switch and case structure. So this actually happens when we're facing multiple options, right? So basically, for example, you could conduct measurements every day and you want to analyze the data of day 1, day 2, day 3, day 4, day 5. And each day of the data uses a different way of analysis, right? So then when you conduct the analysis, let's say if you still use the if and else if, then you're going to test if day is equal to 1. If it's true, you do the analysis else if day equal to 2, and then you do the analysis else if day equals 3, you do the analysis else if day equals 4. So the entire code will look quite cumbersome. You're going to end up having many else if, right? And then you're going to basically have the code of, I mean, it just adds more complexity to unnecessary complexity. But instead, you could do the switch and case structure, right? So you could switch the day, right? Case 1 being this, case 2 being this, case 3, case 4, otherwise, right? Otherwise, basically, it's not any of these specific cases, and then it's going to run to the otherwise command here, or otherwise structure here. Okay, so basically, this is an example that we can test. So suppose we want to create a function that tells user what the airfare is to one of the 3 different cities below, right? So the other thing I want to mention is that typically the switch case structure is more widely used when we're dealing with the the strings or dealing with characters or specific, like when we're dealing with the non-continuous decisions, right? So like I mentioned, day 1, day 2, day 4, day 5, but there's no day 1.5, right? If you want to deal with day 1.5, then it's better to use these type of continuous, I would say continuous decisions, right? The same thing, you can split it to case, let's say New York, case Miami, case Boston, right? So these are discrete or non-continuous conditions, right? So this is one example, right? So let me just delete what I had over here. So you can do city, input, enter, city name, and then put an S here to specify that what we input here is a string. So we're going to talk about the input and output probably in our next few classes. Okay, so now you can switch city, right? Case Boston, right? Display $345, right? So you can do another case, another case, otherwise, file. Okay. So we can change the case numbers, Denver, Honolulu, display, stay home, right, 150. Okay, so and also you can see that when you copy and paste in these structures, the code structure is automatically changed. So under this situation, if you want to change the layout, you can do Control I, right? So let me just type out Control plus I. You can do Control I to adjust the format of all the lines. So now they're aligned. You have different cases aligned really well over here, right? So you can test this function, right? Boston, 345. And then you can type in Denver. You can type in Miami, not on file, right? So this is the case structure. So you can see that if you use the if else, right? So it will be a little bit more cumbersome if, let's say, the input equals exactly Boston, if the input equals exactly Denver, right? If the input is equal to Honolulu, right? Else. So it's a bit longer compared to the switch and case structure here. Okay. So this is one more example about buying gasoline, right? So basically you need to decide first, ask the user to decide which type of unit you're using. You're using gallons or are you using liters, right? So here, so if imagine that you want to buy gasoline. So write a program that first asks the user whether he or she wants to request gasoline in liters or gallons, prompt the user to enter how many units he or she wants, basically how many liters or how many gallons he or she wants to buy, and then calculate the total cost, assuming the gasoline cost is 2.89 per gallon, right? So it wants us to use a switch case structure, right? Switch case, it depends on whether that's gallon or liters, right? So it's similar over here, input, right? The unit you want to input unit, right? So unit you need, right? Gallons or liters. Okay, so if it's gallon, right? So display gallon. If it's liters, display liter, right? And then further, basically here you will determine a factor to be multiplied to the amount that this person wants, right? So if it's gallons, you set the factor to be 1. If it's liters, you set the factor to be basically to convert the gallons to liters to gallons, right? 0.264. Okay. So otherwise, right? So now you have the factors, then we should name it as unit. And then we should ask for how much the how much of the gasoline the user want, right? So amount of gasoline, right? So then here it actually will require a number. Okay. Okay, so then the final cost is going to be amount multiplied by factor and then multiplied by the price, right? The price we know that is 2.89, right? So this is the total cost. So you can run this code. So we can do liters right? You want to buy 10 liters of gas. So you already run it because we sort of hide the result, right? Let's write again, 10 liters, right? So this is the final cost. Okay, so of course you can make the code a little bit nicer, like the answers here, add more input and output, right? So to achieve this this function here. So basically you can see that you can use the switch case function um, to go to different set of codes, right? Similar to if, else um, if and else if conditions, right? Else if and else. So the switch and case construct, so it's often used when a series of programming path options exist for a given variable, depending on its value. So the switch case is similar to if, else, and else if. So as a matter of fact, you can do anything with the switch cases with the if, else, if, and else. However, the code is a little bit easier to read with the switch and case, which is a structure that allows you to choose between multiple outcomes and based on some criterion. The criterion can be either a scalar or number or a string, and in practice, it's used more often with the strings than numbers. Okay, so other than the if and else and case, I mean switch and case, so there could be scenario. For example, if you run this function and it happens to be that um, the user typed in gallons, right? So then, or let's say not this, right? So we just run it again and then we type in gallons, right? We misspell and we forgot about the S. Okay, it's directly going to say not on file. And then when you put in 10, it's still going to give you certain results, but it's not going to give you the right results, right? So it's not on file because there's no factor defined. So under this situation, we want to create something that are easier to interact. So instead of typing, we want it to basically be a interactive interface, right? So this is when we can use the menu. So um, basically, what you can do here is you can create the menu, right? So the unit you need, gallons, and then liters. Okay. So now if you run this, you can see that we have a panel here that allows us to choose, right? So you can use gallons, right? The amount of gasoline, you can type in 20, and then this is total cost. Okay, so I would say the manual type of command is a bit more easier when you want to avoid the typing, right, for the user of your code. Okay, but I would say in terms of engineering calculation, actually, this is not that necessary because we know what we're doing. Okay, so again, this is the example of buying gasoline, and then this is the entire function, right? So I can just quickly copy and paste. So this is going to be problem 6. Well, example 6, score 4. And then now we run it, gallons or liters, right? So this is a nicer way to program, right? You also have all the comments over here. So enter the volume you would like to buy gallons. Let's say we buy 13.5. Okay, so that will be $39.02 for 13.5 gallons. So if you see the output that, or the f print f here, right? So there are some pretty strange symbols, right? For example, this percentage sign 5.2f, percentage sign 5.1, right? So, and then some values over here. So basically, this is the sort of the output format that's used in MATLAB. As I mentioned earlier, we're going to talk about these input and output formats in a class. So likely the next two classes, because we're going to go over these different rules or different formatting requirements when we're dealing with inputs or outputs. Okay. So again, this is the programming structures that we typically use. We talk about the sequence, the pseudocode, and then also the flow chart, right? Selection. We had the if, else, if, and else, and also the switch case structure. And now we can talk about the repetition, which is the loop. Okay, so basically the repetition structure are often called loops, and all loops must consist of five basic parts. First, a parameter used in determining whether or not to end the loop, right? So otherwise, if you don't have the parameter that is defined to end the loop, it's going to run forever, and then your computer basically freeze, right? Or the program freeze. There are definitely ways to break out of the loop. MATLAB has to add that function. And then you need an initialization of this parameter, a way to change the parameter each time through the loop, right? So if you don't change it, similarly, the loop will never stop, right? And then a comparison using the parameter and also a criteria for you to decide whether or not to end the loop. And finally, the calculation to do inside the loop, which is the iteration that you conducted over here. So first is the for loop, okay? So the for loop is a MATLAB construct that allows a sequence of MATLAB statements to be executed more than once. So the for loop repeats a block of commands for a specified number of times. The specified number is established before the loop is executed, okay? So generally, let's say if you want to add numbers, let's say get summation of 1 to n, right? And the n is input by the user, right? And n is defined, let's say defined, predefined. Okay, so for example, we set n to be 10, and we want to get the summation starting from 1 all the way to 10, right? And of course, you can type in 1 plus 2 plus 3 plus 4 plus 5. It's going to take forever, right? There are equations to do that, of course, but there could be some more, I would say, sophisticated calculations involved that are not only 1 plus 2 plus 3, right? So you can add a factor depending on their either even or odd numbers. You can have different calculations, right? So for now, let's try to just get the summation from 1 to 10. So what you do is you will do a for, let's say I define, let's say j, right? That's equal to 1, 1, n, right? So you're defining an array here. J each time will take a value for each of the loop, right? So you can do summation equals the previous summation plus j. Okay, so you can predefine summation starting from 0. And then there's an end. So now you see what it does is that summation initially is 0, right? So the new summation is equal to summation plus j. And then it runs to the next loop, j now equals 2. And then the summation plus j now plus 2, right? And go to next one, 3, fourth one, fifth, all the way to n, which is 10, right? So now let's output summation, right? 55. You want to do 100, right? So you can even show the basically the loop being running, right? So you can output j. If you don't put the semicolon, you can output j, right? So you can see that j is being run through from this iteration, right? Starting from 1, 2, 3, 4, 5, 6, all the way. You can even add, let's say, let's see, print f iteration number, right? So you can see that basically it's indeed running through the loop one by one, right? Iteration number 1, 2, 3, 4, all the way to 100, right? And then eventually you get the summation. Okay. So this is sort of the structure of the for loop, right? So this is a simple example, right? N from 1 to 5, right? Print the value 1, 2, 3, 4, 5. It actually run through all of these different lines. Okay, so you can use a for loop to define element by element a vector, right? So basically now here we're doing the summation, but you can also create a vector. So for example, you can define vector, uh, let's say, yeah, we don't have to predefine vector. So you can just define the vector over here, right? So vector of, let's say, um, J being J, and vector, so define vector 1, vector 2, J being J to the power of 2, right? So now you can imagine vector 1, vector. So now you can imagine that when it's running the loop here, right? So it's basically vector 1 of the first element having the value of 1, vector 2 first element is 1 squared, second element 2 squared, third element. So you're creating an entire array over here, right? So running through 1 to 100. And then you can also check, say, here, CLC. So this is vector 1 and 2, right? So basically, for the for loop or for any of the loops, right, you can define or you can create vectors, you can create matrix, you can also create single scalar like the summation that we just showed earlier. So you can do a conversion chart. So here, this is trying to convert the degree from radians, from degrees to radians, right? So you can use the script over here, right? So degrees from 0 to 360 separated by 10, right? So you define this array, sort of for the degrees that you have to run through, and then you define the radians one by one, right? So start from 0 and then 10, 20, 30, and then you print out degrees and radians. Okay, similar method, right? So you can run, for example, define the J being minus 40, right? Separate by 5 to 100, right? So now you know that the J is actually the degree in C, right? So then we can define F. Let's first define degree C is this, right? J, you can directly use degree C or you can define this again. But basically each time J just take a single value, right? So degree F of J equals 9 over 5 multiplied by J plus 32, right? And then you can show basically degree C and degree F. Oh yeah. So yeah, so it's basically here, the index here have to be a positive value, right? So you have to create something that's positive, right? So then let's see. Or yeah, instead of creating a table, you can directly print it out, right? So what you can do is basically say degree hmm, f is j multiplied by 9 divided by 5 plus 32, right? And then you can do the print f. And then you're going to show j and degree. Let's use the same format over here. So now we can run this, right? So basically it's showing you the degree in Celsius and degree in Fahrenheit, right? So um, originally I wanted to create an array, but then we need to make sure that the array, the index has to be positive. I think that's why you receive this error here, right? Because if you have j being defined in this way, it actually starts from -40. So you cannot have an array that has an index of minus value. Okay. So this is the for loop. You could also use the while loop. So the while loop is done. If you check the for loop, so basically we already defined the iterations, right? The amount of iterations, starting point of iteration, ending point of iteration over here. So the while loop is contingent upon one single condition, right? So basically the loops are allow a sequence of commands to be executed more than one time, right? So the while loop repeat a block of commands as long as the expression control is still true, right? So while certain expression, and then it's going to keep on working on something, right? So basically what you can do is, let's say, while, for example, we still want to get the summation, right? So we'll start from while n equals 1, right? So then while n smaller than 11, right, we're trying to calculate, let's say 111, right? Summation, just define summation, start from 0. So summation equals summation plus n. And then after that, we let n increase by 1. So you see what I'm trying to do, right? Starting from here, n is defined as 1, and then the summation is just 0 plus 1, which is 1. And then I let n increase by 1. Now it's 2, and then it goes back. So it's going to compare, is n smaller than 101? No. If it's not, I mean, it is, right? It is smaller than 101. Then it goes inside. So sort of like when we speak, we say that while something going on, while under certain condition, we will do something, right? So while n is smaller than 101, now n is 2, it goes through here, summation equals the previous summation plus 2, and then I make 2, the n being 2 plus 1, now it's 3, and then go through the loop again and again, again. So now if you output the summation is 50, right? You can try, let's say, only run it for 10 times, get a summation of 55, right? So of course, here I made n increase by 1. And you can imagine if the n doesn't increase, right? If I don't change the condition, if I keep running it, so let's say print f, let's say display stuck in the loop, right? So if I run it, so you can see that it's going to keep running in the loop and never stop, right? Because the n is not changing, right? So it's going to keep adding, 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 and it's stuck in the loop. So under this situation, how do we stop? We can just click the stop sign here, right? It's stop, or you can click or type in Control C. Yeah. I think in Windows, you can type in Control C to break out of the loop, but you can also click just stop to expand, right? From the, or to jump out of the loop. So we have to add a condition that changes the criteria. Okay, so this is an example of the while loop. So n is 0, and then while n is smaller than 5, you print the value, right? The value is n is of n is now starting from 0, right? And then it's going to keep adding. So so after the while statement, an expression is defined that allows the loop to execute as long as the expression is true, right? And this counter here must be changed in the loop, or the loop will run forever, right? In this case, the n is increased by 1 each time. You could also do it increased by 2, right? For example, if you only want to have the summation of even number, or want to have the summation of odd number, or so on, right? So one example with the while loop, or the better that is more suitable for the while loop, is you want to make sure that certain value that's provided by the user satisfy certain criteria. Okay, so you can define number equals -1. If you want to let the user to give you an let's say the positive value, right? So then you can use this loop. Right. So you see initially n, the number is negative, right? While number is negative, basically it goes inside the loop, and then it wants you to put a positive number, right? Or non-negative number. So then you can try -10, and then it doesn't work, right? So it goes back, and then it shows you, right? So it's basically going to keep in this loop until you put a positive number. And you can imagine there's no way we can change this into if else loop, right? So because if else can only run by once. So if it's smaller than 0, then there's no way that you can come back to this loop, right? But for the while scenario, you can keep doing this loop until the user give you a positive number, right? So this is, I would say, some difference between the if else and while, right? But no, not if while, for loop and the while loop. So for loop, you already know what is the number of iteration, right? But while loop, you don't know, okay? So this is an example about calculating the factorial with the while loop, right? Basically, for the while loop, it's going to keep increasing, right? The factor, and then you use the increased factor to multiply by the production. So it's sort of similar to what we had over here doing the summation, right? Remember the summation? So instead of adding, you just multiply, right? So you do the multiply. And then, of course, the initial summation cannot be 0, otherwise it's always 0, right? So I think this will probably run, right? And then, let me see, I have to save it. Summation equals summation multiplied by 1, and now n is 2. Oh, no, so n has to equal to n plus 1, right? So in this way, it does basically the calculation. Okay. So this is one more example about um, um, calculating the harmonic series, right? So basically, you can use the Taylor series expansion to simulate certain value. For example, the log. the log value, right? So log 2 can be simulated by 1 minus 1 over 2 plus 1 over 3 minus 1 over 4 plus 1 over 5. So actually, all of the calculation that's done in MATLAB or Excel are for these type of calculation are done in this way. They use the harmonic series to calculate log or sine or exponential, right? So all of them are done in this way. And actually, there has to be a criteria because you don't know how many terms are needed, right? So when you're trying to simulate, let's say log of 2, right? It could be 5 terms, it could be 6 terms, or it could be 10 terms, right? So is there a way to determine how many terms are needed to simulate this log 2, right? There is a way. So basically, a simple way to do is you can compare, let's say, the difference between the scenario where you have 10 terms and the scenario you have 11 terms, right? And if the difference between these two scenarios are smaller than certain criteria, let's say 0.001, then it means that you satisfy the criteria and you can stop right over there, right? So this is also a while loop, right? So you can imagine, while the difference between the two scenarios are smaller than let's say the difference, the absolute value of adjacent cumulative sum is greater than 0.001. If it's greater than that, add one more term into the summation, right? If it's greater than that, you add one more term. But if it's smaller than 0.001, then you export, right? So you print the value and then plot the results. So due to the time limit, I will basically I will not run or create these code here. But another example I want to show is basically you can break out of certain loops when it already satisfies certain criteria. Okay, so basically you don't have to run through all the loops, especially for the for loop, right? For loop, you specify, let's say, run from n from 1 to 100. You want to run 100 terms, and then let's say if it already converged, right? If it already converged at 50 terms, right? You don't have to run for the rest of the 50 to 100 terms, right? So in that situation, you can add this break function to break out of the loop. Okay, so this is one example. So basically the harmonic series that we showed earlier, that's the Taylor series, and then you can use that to simulate some value. But these series do not necessarily always converge. What it means is that if you add the number together, sometimes it's not going to give you a definite number. It might give you an infinite number, right? So this is one example. Basically, that's you can see that it's 1 minus 2 plus 3, right? Minus 4 plus 5 minus 6 plus 7, so on and so forth. Initially, if you see the first 3 terms, you see, oh, this is 0, right? And then, no, not 0, right? So minus 1, you're going to get 2 minus 4. So it looks like it might end up somewhere, but actually it will diverge, right? So it's similar to the previous problem. You can build up a similar sort of a flow chart, right? So then you can run it through certain number of loops, right? So add the terms one by one. And then if, let's say, the absolute value, let's say that the two terms difference between the two summations are smaller than certain criteria, you can break out, right? So for the terms that are shown in the code here, it's actually shown over here, right? So if the total of this summation minus the total of the previous summation is smaller than the criteria you set it, then you break it out. Unfortunately, for this loop, it never will converge, right? So it will diverge, and then you're going to see the diverge that looks like this. Okay, so actually, I mean, since we get to here, maybe we can also just type in the code. I will not type in the pseudocode, but only the code that is needed here. So basically, it starts from the term of 1, and you can also total will be 1 because you only have one term, right? Criterion, in point zero being, right? If it really converge, right? So max iteration set to be 50. And then for k equals to 1 max iteration, right? So yk, so we're trying to calculate the new term, right? It's -1 to the power of k plus 1 multiplied by k. Let's see. So if k starts from 1, yeah. So basically the next term, let's say y2, the second term will be -1 to the power of 3, which is -1, right? Multiplied by 2, which is minus 2, right? Same as here. If you have k equals 3, then that's 3 -1 to the power of 4, which is 1. So the third term is 3, right? So then you can calculate the total, being total plus y of k, right? And then you can define that, let's say, if total, so define total k, if total k minus total k minus 1 is smaller than criterion, you can break, right? And right, in the end, you can plot basically the total, right? So you can also show the iteration, right? Show the, let's say, display. Let's just show the iteration by just typing in k, okay? Let's see. So it looks like it directly stopped. So what happened here? You have k, yk is equal to 2 minus 2. Okay, so it should be total k minus 1. Okay. Should be absolute. So the absolute value is smaller than criterion, right? So it shouldn't be, if it's negative, right? -10, it still doesn't satisfy. So now you have the, let's say the summation, right? As a function of the iteration, right? So you can see that it actually doesn't converge. And then you have to run through all of these. Okay. So this is the break function, right? You already see that earlier actually the loop break out mainly because we didn't add the absolute function over here, right? So when it gets to a negative value, it just breaks out. Okay. So I mean, since we already have the code here, we can also try the code over here, right? So you can define, let's say, y1 being 1, and then total being 1 here, right? Max iteration 50. And then you can define this k term, which is -1 to the power of k plus 1 divided by k, right? So the first term is 1, second term is -1 to the power of 2, or let's see. Okay, to the power of 3 divided by 2, right? So minus 1 over 2. So then we can run this. So you can see that actually tries to converge, right? So the summation tries to converge here. And then you can also set the maximum iteration to be 100, right? So we iterated by 100, right? So you can see that still, right, it's getting very close. Let's try 1,000, let's say 10,000. Ah, I see. So you see that the iteration stopped at around 100 or 101. This is mainly because now the difference is actually smaller than 0.01. Okay, so you can, let's say, set it to be 0.001, which is going to give you like a more converged results, right? So you can see that when the iteration is 1,000, it still hasn't satisfied. Oh, at 1,000, it satisfied the requirement, but here it didn't run all the way to 10,000. Okay, so it breaks out from the iteration. Okay, so these are the, I would say, examples of using iteration. This is for summation. You can use that for calculating, let's say, production or all types of scenarios that might need iterations. Right. So the next is the nested loops. So basically the nested loops are iterations within iterations. So for example, if you have a matrix, you might want to, for example, go to the use the first row doing some calculation and then run through different columns, first row, and then second row, run through different columns, third row, run through different columns, fourth row. So then what that means is that you can run specific column, right? Column 1, and then do the for of each element of the row, right? Column 2, each element of the row. So this is called nested loops or loops in loops, right? So this is basically how the max function is defined in MATLAB, right? Remember we said that the max, if you want to find the max of all the elements within a matrix, right? So it actually conducts this calculation to compare elements one by one by using the nested loops. And finally, I want to mention about the efficiencies of loops. Okay, so a lot of times it's much easier for us to predefine certain variable or certain array or certain matrix before we run into the loop and create the matrix element by element. So what it means is here, so if you want to calculate multiply a matrix, right? So for example, if you define a matrix of 1 with a dimension of 1,000 by 1,000, right? So then let's say we start from A equals this thing, right? And then you can do T0 equals clock, and then B equals A multiplied by pi, right? You just multiply A by pi for all the elements and define this B, right? And then time equals B time clock T0. So it'll give you the time, right? The time for generating this new B element is 0.0069 seconds. And you could also create the matrix line by line, right? Line by line will look like this. So T0 equals clock. And then we can type in for A equals 1 length A, basically the columns, right? B, K equals A, K multiplied by pi. And then run this. So basically here, we already defined A. What we're trying to do is we're running through the columns, right? And then for each column, we define a new B column that equals the A specific column multiplied by pi, right? So basically there's no existing space for B, and we're just adding the B column by column, right? So then you see that the time is longer compared to now here, right? In the beginning. In the beginning, it's just multiplication, right? Here, since we didn't allocate B for any space, then the time is a little bit longer. So now we can try the third one, which is we can predefine pre-allocate B some space, right? So we can first allocate B because we know that the B will have the same space as A, right? So we can it's still going to be the same type of code, right? T0 equals clock. And now we just need to give B some space in the RAM, right? And then run through this because compared to the code here, the computer doesn't know what space the B needs, right? It has to allocate space, new space one by one, right? But here it already allocates some space for the B. And then you're just sort of filling in the values to the allocated space. And now if you run, you can see that it's much shorter, right? So this is about the efficiency of the loops. So it's always better to predefine the parameter in terms of its length, in terms of its size. It's easier, or if you want to save some time in your code, right? It's easier in this way. So as a summary for this class, I think we covered quite a lot of contents. It's also a long lecture here. So the loops are MATLAB constructs that allow a sequence of MATLAB statements to be executed more than once, right? The for loops repeat a block of commands for a specified number of times and that is specified before the loop is executed. So we know where it's starting, where it's ending, and also the interval, right? But the while loop doesn't know that, right? It repeats the blocks as long as the expression is true, right? And then in the beginning, we also sort of covered different structures, right? There are decisions. We talked about the if, else if construct, switch and case construct, and finally the menu, right? So where if you want to minimize the efforts in typing in the correct strings. Okay, so I would say that's it for this class. This class we covered quite a lot of contents. So do practice with the problems that are showing here in your homework problems. So these structures or these type of I would say programming tools will be very helpful when you're starting to um, know a little bit more sophisticated programming in the future, right? Or in the next few classes. All right. So nice talking to you all, and let me know if you have any questions.